Hello, hello, hello. How are we doing today? Just end. There we go. Yes, me too. Alright. Yeah, fair enough. Really need to make this a little better. It's going. %4? %4. It's gonna work. It's going. Alright, you go downstairs? Yeah, it's great. I don't get Godot completely yet. Yes. Okay, honey, go downstairs, alright? Thank you. Yes, 2 separate classes. Should be demonstrating the separation. Happy to. Hey, it jiggles. Well, I guess the they should demonstrate different objects, if that makes sense. Because I believe you did them in C, right? So you should if you have a view that's showing the full listing and a view that's showing a specific product page, they would be two different objects, I would assume. Alright, we need to do some inheritance. Hey, we got 1 minute here. Vector to array, indexed vector. That's what we want. Need to abstract that out so that it's not called in a million places. Bad, don't do this. Yeah, I'm not gonna do that. Let's abstract it. Is Godot in here? Yeah, no extension. Alright, let's put that in there. Up. And this needs to have this. That's for something else. Hey, it's 1 o'clock. Look at that. Oh, you did Java. I thought for some reason I was thinking you did C. That was another person. Yeah, that's right, because you even showed me yesterday, or the other day, what you did. Yeah, you just have to separate them out, is kind of the point. Alright, enough synthwave. Up, up, up. Hmm. Hmm. Over here, please. You can move. There we go. Alright, I'm seeing some ambiguity in understanding here. Does anybody have... So for the... Yeah, you can show me later, that's fine. Weird fan noises happening. So let's talk the homework, I guess, for a hot second here. Not have it open. Of course I don't have it open. Why would I have it open? That would make life so much easier. There we go. All right, so you should be implementing MVC. M lost. Okay. Sorry, I don't mean to lose you. So the goal is to implement MVC, right? So I didn't really specify a specific way you should class this out. But if you're doing MVC, you're going to have a model, which would be your list of stem toys, right? You'd have some model that would house this list of objects and their attributes. You would have a controller that routes and gets that data and returns it to the view. And then you're going to have two views, right? So you're going to have a product listing view and a detailed product information view. So when I read this as somebody familiar with MVC, I'm seeing two different displays that are showing, right? It's not just one. I would read this as two separate classes. Now they might be subclasses, but they're two different things. So product listing would be the list of all these STEM toys, and I would see that as a class. Here's an array list of objects, methods for click, and all that fun stuff. Just making Python terminal. Yeah, tkinter is interesting. Yeah, that seems reasonable. Basically, I think maybe the confusion, maybe I misspoke or something, but this and this are two different perspectives of the data. If I update something in the detailed view, that doesn't necessarily impact the product listing view. If I update the screen, That's fine. The point is your representation of these views. So I'd kind of expect to see in your UML diagram class product listing, class detailed product, right? So you'd have like class product for that. The implementation is separate, really. Like if you have to add a new attribute to the detailed view, like if you add, I don't know, product color or product material or country of origin, that won't impact your product listing. And vice versa. If you make a change to how you list out products, that's not going to impact your detailed view. That's that separation idea that we've been talking about. I guess if you're still lost, please let me know, I guess afterwards too. We can chat in detail. Maybe it'd be a little bit easier than one-way voice and slightly delayed text. Yeah. All right. Using controller determine what's displayed on the view using KWRs. I could see that. That's Python, C, other languages gets a little bit iffy in what you're doing, right? Possibly not what I wanted. I like to leave ambiguity in the homework assignment to make it arguable, I suppose. If you can argue that it is MVC, I probably will be more or less okay with it. If it's very clearly not MVC, then I will have a problem with it. Alrighty, let's talk interfaces. We can keep this conversation going after class 2. So we ended right about here last time, right? We were talking about reuse, composition, inheritance, basically trying to figure out how things can be maintained and reused over time. We left off here at interfaces, and we kind of talked about these a little bit before, but let's go into them in a little bit more detail here. So an interface is basically going to be a front end that you call where whichever attributes or methods you're referencing will actually be abstractions for specific subclasses further down the line. So here we have a interface called movable, and this example here is basically like a graphics application. Like you're drawing a point, or you're drawing a circle, or a square, or a polygon, or something like that. It's based around this notion of points. So we have a specific class called movable point. And what that's going to do is it's going to figure out where the X and Y position is. So it's pixel location, and then give it a speed so that point can move around. And this then would go into how we bring in these other objects. So here you've got a circle that can move around. It needs that reference to a point, but it's got a radius. Right? If you wanted to add a square, that would not impact your interface. It wouldn't impact your movable point. You would have 2 points to define like the top left and bottom right corner, and then you know how to fill in the blanks to draw a square. Each of those points would move independently, but they would basically kind of move as part of this object. Now you might be looking at this and saying, well, this doesn't really look like an interface or anything like that. The key here is that what's happening behind the interface is up to interpretation. So you don't need like a movable point and then an aggregation of other objects. This could be, let's say that we're describing a generic vehicle. This could be interface vehicle. This could be boat. This could be car. This could be truck. This could be bicycle, submarine, so on and so forth. Basically, the key here is that in our interface, we have some methods here which match methods in our classes behind the interface. And then whenever I call movable.moveUp, it's going to call the associated function with whichever class we are looking at. Now, the benefit to doing this is you get a very nice reuse capability here where I don't care what the type is behind the scenes. I just know that I have this movable object, and I call move up. It's going to move forward. Whether it is a truck, whether it is a pixel, whether it is a submarine, I don't care. It's going to call its own function, but the front end client that's interacting with this object doesn't know that. Kind of goes with that data hiding principle that we talked about last time as well, where if you are outside of our class, to do a little throwback to what's probably an ancient movie now, outside of your circle of trust, um, you don't need to know what the data looks like. You don't need to know what the class structure looks like. Don't care if the speed is derived or set directly. All you want to do is move it. So then you would call this kind of an interface thing. And again, don't get hung up on this aggregation here. There doesn't need to be a connection. The key is this set of methods, this set of methods, this set of methods right there bolded there. That's what you should focus on. So more formally, an interface and how we can basically enable reuse with it is that we're not going to care the type behind the scenes. This is just a front-end class providing a set of methods to interface with everything else. You can have one or more interfaces, or I guess 0 or more if you don't want to implement it. But you could have multiple interfaces for clients to call. So let's go back to that example for vehicles, where we have multiple vehicles here. You could move. You could also refuel. That could be another type of interface where car is going to take gas, submarine's going to take a nuclear rod or something like that. All right, we have a lot of different things that we can do where we want to abstract things out. It's kind of nice in that regard. So, other things that we care about here. Since we are using this principle of data hiding and data privacy, of encapsulation from last time, we can have different objects being plugged into this, right? They're all going to be encapsulated within themselves. They're going to be passed in, and they're effectively going to be called. Again, we have to make sure these methods match. It's not strictly like a facade where we're providing an easy-to-use interface and the power users know what's happening behind the scenes. No, this is pure abstraction. Nobody can see behind the interface. The only way you can is if you are like a subclass or some kind of encapsulation breaking pattern where you can get into there. But this quote that I've got here at the bottom, and we've said this a few times in the set of slides, program to an interface, not an implementation. If you look at something like this, you can really hopefully see how useful it can be. Now, is there extra overhead? Absolutely, right? You have to understand how interfaces work. We're going to look at an example in Java and Python in a little bit. But for a simple project, this is probably overkill, right? Some of you that are making games, for instance, are probably going to have different types of objects that can move around the screen. You might implement an interface where each of them has a movable interface, right? Move north, south, east, west, attack, up, down, left, right, rest, whatever your objects have to do, as long as they're similar calls. Rather than iterate over every single object in your list and handle them differently, you could treat them all. This is basically almost like an entity system where you iterate over every single object and call object.move. And you don't care if it's move with data coming from the player or data coming from the AI entity. It's just going to handle that procedure. So this is kind of like a client front end type of thing where it makes life easier in that regard, in a way. Other thing to consider here too is that for simple projects, this might be overkill. Same goes with any of our design patterns we talked about. But when you start scaling your project up in complexity, when you start adding team members, when you start adding extra modules, extra details, it can very quickly become a spaghetti code mess of millions of function calls that you're all handling separately. But if you interface things out, then it becomes a little bit more simple in a way. It also leads to nice parallelization possibilities as well. Now, some advantages to doing this. The client, again, they don't care what the class is. Using that vehicle example, they don't care if it's class submarine, class human-powered bicycle, gerbil-powered hamster wheel, or hamster-powered hamster wheel. They don't care. They just want to see things happen. So that's your front-end developer right there. You can very easily plug and play objects in here too. as long as you're satisfying the interface characteristics, right? You're implementing the correct methods. Um, interface doesn't care. It's going to call it regardless. You're going to basically get a nice benefit of ideally easier to use code and easier to read code, honestly. We also start talking about some notions of coupling and cohesion. We'll talk about those again. We talked about them last time. We're going to more formally define them here now. But basically, your classes become more single-focused in a way. So that's higher cohesion. The vehicle class is only focused on the vehicle class. The submarine class is only focused on the submarine class. We're also loosening our coupling between objects. And right, that's, if we remember from before, coupling is where classes are so like intertwined that if you try to break them apart in some way or you make an update, it's going to require an update over here, which is bad because you want objects that are here, you want to make an update. You don't want that to impact everything else. That's kind of why you're all doing the model view controller as homework, to hopefully demonstrate that concept, right, with your multiple views. I should have had you do multiple models, but I didn't want to be too mean for that. So coupling and cohesion, definitely things we can get out of interfaces. We also get good reuse, right? You want to add a new object, very easy. Just make sure it implements the right methods and you're pretty much set to go. Disadvantages. Modest increase in design complexity. Now that's kind of arguable in a way, right? So let's look at this model here. Doesn't look super complicated, right? This is a very simple interface. Consider, though, that projects are a lot more complicated than this, right? So this might be one interface of many. We might have associations down inside the interface. Like here we have an aggregation. You might have compositions. You might have any number of class diagram tricks going on here. But the idea is simple. Have an interface. Client instantiates interface. Interface handles the connections to all the classes behind the scenes. Just again, the key are these methods that you're implementing. The complexity kind of comes in the language particular side of things, right? So Java, it's actually pretty straightforward. We've got an example here where the keyword interface is baked right into the language. So you don't really have to go and yank any extra modules in or do any real trickery to make this happen, right? This language really supports this notion. Python, C++, C, you have to go do some other things. We'll talk about Python in a moment. But really, it's very easy, and honestly, I would recommend doing this if you have multiple objects that are doing the same thing, just in different ways. All right, so let's look at a vehicle example here in Java. Again, this is another one of those examples where I'm going to show you the Java code. I'm going to assume that you know how to implement it. Then I'm going to show you Python code that actually works, because personal bias, which is perfectly fine to have. So here we have a iManeuverable class here. And this is an interface. So we'd say public interface iManeuverable. This tells Java this will act as an interface. Expect varying class types coming in later on. And what can this interface do? We can turn in various directions, move forwards, move in reverse. You can climb, you can dive, and then you can set and get the speed. Now, again, data hiding principles here. Don't directly set internal variables if you can avoid it. Have a get or a set function there to protect yourself. Now, would it be easy to say car.setSpeed 50 miles an hour? Sure. It would be easy to say car.speed equals 50, but you should be doing car.setSpeed equals setSpeed 50, for instance. And again, why do we do that? That enables that concept of defensive programming that we brought up last time, where I, as the client, could either intentionally or unintentionally set this variable wrong. And if I have direct access, I can really break things, right? Vehicle.speed equals 500,000 probably will break the rest of the system. Whether it's physically possible or not depends on your simulation that you're running here. But set speed, you could protect against that. If speed is greater than 100, assert an error or something of that nature, right? So you have your interface here, and the idea would be that the classes that are implementing this interface have these methods. So what do we have next? We've got some class declarations which don't actually have the code. Assume that the functions are defined in the code here spaces. But the way it works is that you would define your class, and then you'd say it implements interface. That means that when we define car, we're going to expect to have definitions for these methods in there. Right, so car implements, boat implements, submarine implements, bicycle implements. We are generating a list of varying types, but they all have the same methods. Again, that makes it easy for us to just iterate over all of them and move them or do something. Oh, thank you. Appreciate that. So let's look at an example here. So everything we talked about before was in our, effectively like our headers in a way, or our class definitions, not application-centric or client-centric. Here we have what is actually going on in your main program. All right, so here we are going to maneuver a vehicle where we don't care what that vehicle is. Right, so again, different entity types, different object types, but they have the same methods. So here we have these three: car, boat, submarine. Don't care. Pretend that we're calling travel, iterating over a list of vehicles. Now it's going to take an iManeuverable, so this is the interface type, whatever you called it. Probably, hopefully, should notice that we preface it with I to distinguish that it's an interface, but depends on your style guide. So travel, vehicle. Again, don't care the type. Set its speed to 35. Make it move forward. Make it turn left. Then climb. This could be a submarine buoying itself up. It could be a vehicle going up a very steep grade and going into four-wheel drive. Again, we don't care from the client perspective. The class is responsible for that. And you can hopefully see here the fact that we're breaking these classes apart, right? Each vehicle is only concerned with itself. If I want to add a new type, a new vehicle type, sorry, I don't have to change submarine. I don't have to change vehicle. I don't even have to change the interface. I just add this new encapsulated object into the system, and it will be fine. What happens though if my interface, sorry, if my class does not implement forward? That would, in Java, honestly, I'm not sure if you'd get a compiler error or a runtime error. I would guess a runtime error, but maybe Eclipse is smart enough to catch that. Probably would catch it at compile time. But it's not going to know what to do, so it will fail in some way, either when you hit compile or execute. But you need that. So that's the Java example. Again, pretty easy. Now in Python, you can do this as well. You can do it in C and C++. C# is going to be similar to Java and how it handles interfaces. But for Python, I need to put this up because I didn't update the slides in Blackboard. And I said that at 10 a.m. as well, so I should probably fix that for everybody. We have a couple of concepts in Python and how we can do interfaces, which is why you have 3 links here. So you can do it yourself using Python's duck typing, if anybody's heard of that before. It's a very fun little definition where I think it goes, if it walks like a duck and quacks like a duck, it's probably a duck. And that's the literal Python definition for how they handle typing. The idea there is that if you have some object that you do common operations on, like a string or a list or something like that, and you have operations like print, where you can print that information, len to get the length of it, type to get its type. If you're defining a new class and you want to treat it like a string, provide the operations for stringing for string operations, and then Python doesn't care. It will just call whatever the print function is, whatever the len operation is, and it will treat it like the object you expect it to be. You can kind of use that notion to coerce out an interface, where if you make an interface class and then a bunch of other classes, as long as they all implement the appropriate methods, right? If you match methods, then Python doesn't care. It will assume it's an interface. So it's very loose in how it handles rules natively. There is also something called the abstract base class, so that's the ABC. It's this last link here if you want to read up on it. Basically, it enforces more rigor in how Python handles typing and things of that nature. The one that I'm going to show is this Zoop module. Interface example. So basically, this is just a external third-party module. You can install it through pip or easy install or something like that. But basically, it enforces another layer of rigor into some of this like object-oriented class trickery that we can do. Makes it Java-esque in a way. If you install Zope, it takes a long time because it pulls in a lot of other modules. I even saw it pulling down Beautiful Soup, which is interesting because that's like a web scraper. But basically, it's got a lot of dependencies. However, what I care about here is it implements an interface. And it's very, very similar to the Java style, which is nice for class examples, honestly. More dependencies is more better. It becomes like an NPM repo, basically. All right, so let's import the interface aspect of it. And then what we're going to do here is we'll define our interface, and then our implementers, or the classes that implement the interface. Same idea with the vehicles before. So this class here, we're going to say it inherits from the interface, which turns it into an interface. We're going to define some attributes and some methods. Right, and we don't care, like we don't add code in here unless you need it to do something for everybody. But basically we're just going to pass, and that's just going to basically skip execution here. But later on, I've got two classes that I define here. So one of them is the boilerplate tutorial straight from that web page that I have there. And then I modified it for 350 here. So basically the default, we have a decorator to say this is an implementer. Basically, we're telling the Python interpreter, make sure this is an implementer for our interface class. And Zope basically defines the decorator there. There's baked in ones as well. So then class, my class, hey, we have methods for method 1 and method 2. Method 1 only takes in one parameter, even though we have 3 available. So this particular instantiation only needs 1, which is fine. What's it doing? Well, let's square whatever variable's coming in, and then method 2 lets us return a string. Again, simple demonstration purposes, you could extend this to do whatever you want. This could be move forward, climb, move backwards, set speed, etc., etc. So the other one that I created here, instead of squaring one number, let's raise one number to the power of another, and then the second method will return, hey, 350 is somewhat neat. So that's what we're doing. So to relate it back to the other example, 2 different vehicle types to one interface. All right, so we instantiate them here. So I am not instantiating the interface. That's being handled through this class declaration here. And then a bunch of print statements. So the ones that are going to look like types or true or false or something like that, these are the boilerplate examples from the website that I've got linked there. Basically, it's just demonstrating who implements whom, is an interface available, is a method available, things of that nature. So it's going to look like a bunch of true, false lists, things like that. The end, though, are going to be print statements for the output of the methods. So my class in CIS350, what is method 1 doing? What is method 2 doing? We'll see that pop up. All right, so let's run this. Python. So true, false, true. This is basically, is an interface implemented by a class? Yes. Is an interface provided by a class? No. Is an interface provided by an object? Yes. What are the types? It's an interface. It's an interface. And then we get down to our methods here. So what is 4 squared? 16. Hey, look at that right there. Method 2, again, we're returning a string. For object type 1, it returned foo. For object type 2, and returned our other string. Method 1, 4 to the power of 8, 65536. Okay, pretty neat. Now, why is this neat and why do I care again? I'm just calling object.method1, right? It's totally abstracted out. I could just as easily loop over every single object and say object.method1. Actually, let's do that just for fun, because it kind of demonstrates better than printing this out. So let's say objects equals obj1 or obj2. So I've got two objects in a list. They're different types. For O in objects, print O dot method 2. That should work. So, let's get rid of all the other prints too, because it's going to clutter things up. And all right, comment it out. Let's even add another class just for fun. Vehicle, car class. I am a car. Beep, beep, Richie. Car equals car class. So now I have a generic object, I have a CIS350 object, and now a car class. For fun, because why not? Oops. I did not add it to my list, so it's just car. Here's all of my output there. And again, consider that this is something more complicated than printing a screen. We are updating internal game logic, we are ticking through enemy AI state machines, we are doing collision detection, we're doing anything where we can abstract out a similar operation. And again, rather than going for I in, or for entity in players, for entity in enemies, for rocks, for trees, for going through every single thing, we just have one global list and we just call this common method. That makes life even easier if you want to parallelize here, right? So I could just thread this out, run a certain number of worker threads, and for each worker thread, just call that generic method. Then I get performance gains because this is all the same operation. So to me, this is kind of a nifty little thing that you can do at very little cost. I mean, I don't know how big the Zope library is in Python. It seems pretty big, but not hard to implement in the least, especially if you're, not a super great Python programmer. It's very, very easy to get up and running. But there's other ways to do it, which are harder if you don't use a library like that. So it is ish. So basically you could basically you have to define abstract methods and you have to get a little bit deeper into some of these decorators. So the links that I've got there will kind of walk you through some of them. I mean, basically all we're really doing is just kind of coercing Python to use better data hiding principles and things like that. That's the thing with libraries. Hopefully it makes them easier. But yeah, it's a neat little trick that you can do. This one trick made all programming obsolete. It may surprise you. That to be my it's my lead-in clip for this video. All right, so interfaces, nifty thing to have in your tool belt. Now let's talk about actually quantifying quality. So back in the 70s, and again, this is about the time we start talking about data hiding, things of that nature, before we even have object-oriented programming, people were trying to think, how can you actually assess quality? And this sounds kind of weird to a programmer. Of course, it's going to be perfect code. But if you sit and look at it like a project manager or a quality assurance person, and you're looking at a list of code or you're looking at modules or UML diagrams, how do I know if this is better than this? Or how crappy is your code base and how much better could we make it? Well, what came out of this was the notion of cohesion and coupling. And I've been talking about this in terms of like class diagrams, um, basically at the class level, but this can really be implemented at any level. So it could be at the function level, could be the class level, could be the object level, could even be higher up. It just depends on what your perspective of the system is. And are you looking at UML? Are you looking at code? Are you looking at your design documents, right? It's the notions hold wherever you go. And again, cohesion is the focus of your object, and the coupling is how tightly intertwined multiple objects are. And again, we care about these things because if things are intertwined, that means change here means change over here. And that's not good if you have a project team, for instance, and you're working on your module, you're working on your module, and every time you make a change over here, everybody over here has to make an update to handle this change. That's bad coupling right there. It takes time and effort is kind of the takeaway. And the less time that we have to be fixing other people's problems, the better. All right, so I'm going to pop all of these up on the screen here. Sometimes I like animating them out, sometimes I don't. Just depends on my mood. But we're going to start with cohesion. And we have a ranking of the different types of cohesion in order of most desirable to least desirable. Basically, good cohesion or bad cohesion. So we start off here with functional. This is basically going to be that parts of the module are going to be grouped together because they're basically doing the same job. Right, so they are very highly focused on one task. Let's group them together in a module or a class or a method, right? It's object of some kind. So that's single purpose, single focus, ideal. But we go down in ranking here. So sequential cohesion, this is going to be because like the output of one module is the input of another. So it's things are happening in sequence. It's grouped in that fashion because of this relationship. Not as good, but still okay, right? It kind of makes sense. You have communication cohesion. Maybe we are acting on the same types of data, right? We are handling the same messages, talking to the same data sets, things of that nature. Basically, we're communicating. Not as good. We also have procedural. Basically, this was kind of similar to sequential, but it's not output of one is the input of another. It is we are executing a certain number of functions in a particular way. Maybe we make some kind of a query, then we do this on the query, then we handle the data, then we display the data. That'd be procedural. Function call, function call, function call. Not as good as sequential, but it's similar in notion. We have temporal cohesion. So this is basically time-based. Things happen at a particular time. So activities or events, items of that nature, we're going to group them together based on timing. Not as good. Many different types of things could happen at the same time. Doesn't always make sense to group them. You have logical cohesion then. This is where you have similar events happening, but they might be implemented wildly differently. Good example is handling input from a user. Could be handling keyboard input, mouse input, tablet input, touchscreen gestures, eye tracking, voice recognition, right? They're all the same idea, but they're implemented wildly differently. And while it might make sense to group them, the implementations under the hood are so different that it's actually going to be more difficult than not to group them. At a high level, maybe group them, but not at a low class level. Then we have coincidental, which means we just kind of lump things together because we feel like it. So worst/least desirable there. Now, question to you all. Let's say that we have a module and it is not very well focused, so coincidental cohesion. How would you improve cohesion? So basically, what would you do to improve the cohesiveness of a module? I am realizing that this tea that I made, I steeped it for too long and burned the tea leaves. Rookie mistake. Very bitter. Restructure so that like modules are placed together. That's a good answer. I like that one. Other things we can do too, but that's definitely a good start. Definitely a good example of what you could do. So maybe like break apart a package and refocus them. Yeah, no, that would be an example. Better. All right, any other guesses? Hmm. We need some dancing crabs to liven this up. More related methods and variables. Yeah, so that's the general idea, right? Things should be focused. So the spoiler here, I guess one of the other answers that I'd be looking for too, be very explicit with names and types. Hey, that makes sense. There's not any ambiguity then. So good guess, definitely. I like that one. Other thing you could do is kind of, I guess, related. So if you have a complicated class, break it apart and restructure it into smaller classes. So if you have a large vehicle class that's implementing all these different methods for what a vehicle does, maybe break it apart into components. So have the drivetrain class, have the steering class, have the radio class, and all that. And then probably compose them together into a generic vehicle class. But instead of having each separate individual method in there, it just references these subcomponents. So it's kind of like that first example, restructure. So yeah, restructure, break things apart, refocus them. So all very good answers here. Good job. And this is going to be effectively the definitions of what I talked about earlier. So if you weren't paying attention, here's exactly what I said. So here's an example of a class with low and high cohesion. So here on the left, we are doing email, maybe sending letters. So it could be a payroll department, right? You're either doing direct deposit and getting an email, or you're getting a check in the mail. Here, we have low cohesion. It's doing too much. It would be better to split this off into subclasses where they are each very highly focused. And then here, we might have like a reference to each subclass. Now, to me, this is going a little bit above and beyond, right? We don't need a class for every separate function. Maybe check email, validate email, send email. These might be one class, and all the letter specific things are another class. It's possible to go too overboard with it, but it's a nice example of breaking things apart, really. So that's cohesion. The other side is coupling. Now, I'll show this figure and then we'll go back and talk about it. Again, coupling is dependency between classes, between modules. We don't have a great visual of what high coupling looks like or tight coupling looks like, but you get kind of this type of a picture with your various modules that you have for classes. So here, this is very tight coupling. You see there's a lot of overlap. And overlap could be classes calling one another's methods, classes acting upon each other's data. Basically, like if I've got, again, I keep doing this in my hands, they're very tightly interwoven. You can't easily break them apart. And the idea here is that let's say that I change some variables around in class A. Let's call this one class A. That means that anything interacting with that variable has to update its own methods. Or these could be operations, right? If we have a lot of dependencies between classes, it can get very messy if you ever need to refactor or maintain things. Better would be to have everything be nicely separated, and rather than directly acting upon each other's methods, right, maybe reference a facade, reference an interface of some kind, where maybe we just have a get and a set operation happening here. Or we have very simple interactions we call something internal to the class. Basically, you logically break apart all these dependencies. And again, I'm sounding like a broken record here, but let's say that I want to add a new feature into this class. That doesn't impact anybody else in theory, right? If it's like a variable that we're getting in setting based on this, okay, maybe we have to update it, maybe we don't, but there's less risk if you do that. All right, so coupling then, degree of dependence. Basically, we have a couple of ways of looking at it. Could be a normal coupling where we have some parameter calls, basically some kind of a simple interaction. For the cohesion thing, do we just call the print some class letter address functions? So that's back here, right? Yeah, so if you wanted to split this up into a figure like this, let's call this superclass. Superclass would get a reference to class A, and then we just say class A.process, class B.process, class C.process, or something of that nature. So you could almost roll in the interface notion here. Basically let each subclass do its own thing and just indirectly reference it. All right, so back to coupling then. So normal coupling, minimal dependence, just parameter, simple call interaction. Common coupling, not as good. You're both acting on some kind of a global data store, right? Where if I change something in this global data set, maybe it's a variable, maybe it's a list, it's going to impact every other class using that data. Again, not necessarily a bad thing, but just something to be aware of, that a change here impacts everybody else. And the bottom, not as good. Content coupling, this is where you are, again, directly referencing the internal mechanisms of these classes, whether it's data, whether it's methods. You are tightly intertwined. So, coupling. All right, a few questions for you, and then we're all done, and you all get to go have a wonderful weekend, I hope. So we talked about OOP, probably in the most detail, especially when we talked about design patterns, but we also did analysis and design. So I just want to kind of leave you with this notion. We're not going to get to the question for what's better, what's worse. The spoiler is that they're all necessary. You should allocate appropriate time to analysis, design, and programming because you're going to identify domain problems, implementation problems, logic problems. Basically, you need time to develop a project. But this first point about design patterns in OOP, D, and A, consider that these design patterns are basically common patterns that we have found in software engineering, whether it's at the implementation level, whether it's at the project management level, the design level. These patterns exist. Design pattern wise, we looked at everything pretty much implementation wise, right? We looked at facade and visitor and singleton and all that fun stuff. Basically how you lay out your class diagrams, what the interactions and relationships are. But if you also remember when we talked about anti-patterns, we had some project management ones, right? We had business level ones. And if we slide over to that, here, we actually see patterns that exist, right? There's the death march. We know a project's going to fail, yet we keep doing it anyway. There's scope creep, which I'm sure some of you are realizing in your term projects. The point is that all of these activities that you're going to be doing at the software engineering layer or level, again, you don't have to be a programmer to be a software engineer. You can be somebody doing analysis or design. It's all part of this field. We're going to have patterns that really reflect what you're doing. And the point of a pattern is it's either going to be a common good practice to apply, and if you get on early with this pattern, it's going to make your life easier. Or you fall into one of these anti-patterns and you realize, well, crap, we're doing something horrible. How do we fix this? Key is that design patterns apply at all levels. So being aware of these patterns and anti-patterns is probably going to be a good thing for you. And is one better than the other? No, they're all relevant, they're all required. One being OOPD array. Alrighty, that is pretty much it for today. So what I'm going to do is I'm going to pull this PDF down before I forget once more and update this. Anybody have any questions before I let you all go? Anything at all? No questions from me, thanks. Awesome. Well, then I hope you all have a great weekend. I will see you all on Monday, refreshed and ready to talk about decomposition. All right. I'm gonna say bye everybody, and I'm gonna leave it on while I upload this so you can see the photographic evidence of slides being updated. And we also need some code. Did I really put it in here? I did put it in here. All right, well, guess it's going in object-oriented then. Hey, this is what Blackboard looks like from behind the scenes. It's Geeks for Geeks. Yeah. Oh, come on. Interface. Oh my god, so many pop-ups. Yeah, here we go. So from here, there we go. Got that. I guess we'll give it to section 2 as well. We'll just be nice to them. Alrighty, and that's that. Have a great